All right, this is the relearn of Objective 2.1e. Mostly what we're doing here is we are going to use the graphing calculator to come up with an equation and use that to predict answers. So the first one says the scatter plot shows the number of mistakes a piano student makes during a recital versus the amount of time the student practiced for the recital. How many mistakes do you expect the student to make at the recital after 10 hours of practicing? We're just going to use the graph to get that. So 10 hours of practicing, that would be on the x-axis. So find 10 on the x-axis and just follow that up till you hit your graph. And then to find the number of mistakes, you're just going to estimate where that spot is on the y-axis. So I'm going to guess about 43 mistakes. You guys agree with that answer? About 43? You could probably say 44, 42, I don't know. All right, so we're just using the graph to help us make an estimate there. All right, number 2 says use a graphing calculator to find the equation of the line of best fit for the data, predict the missing value in the table. Whenever you deal with years, it's a lot easier to not have to put that whole great big year in there in your calculator. So let's say we're starting at the year 2000 and we're going to just say how many years since the year 2000 do we have. So we're just going to put in a 1 there, a 2, a 3, a 4, a 5, 6, 7, 8. And we're not going to enter this because this is the value we're going to predict. We're going to try and come up with an equation to predict that missing value. So what I'm going to ask you to do now is press the stat button on your calculator and then enter and put the values 1, 2, 3, 4, 5, 6, 7, and 8 in L1, and then put these distances in L2, and then we'll go through the steps of how to make the equation for that. So I'm going to pause right now and get those values in my calculator, and you should put those in yours. All right, I have my values in my calculator, and now I want the calculator to come up with an equation we can use to predict that missing amount. And the way we do that is we do the thing called the linear regression. To get to the linear regression, quit, which is second mode. So you're just on the regular calculating screen. I'm just clearing my screen. You guys good with that? Yeah. All right, and the linear regression is you press stat, and then arrow over to calc, and then we pick number 4. And then once you get there, you press enter. And it tells us our equation. And I'm just going to round those values. They don't have to be perfect, but y is equal to, let's round it to 0.47 x plus 68.4. Now, what we want to do is predict 2009. X is our year and Y is our distance. So I need to put the 2009 in there for X, but remember I'm not using the whole year, I'm just using 9. So what I'm going to do is 0.47 times 9 plus 68.4. And that's my answer, that's my prediction. So go back to your calculator. 0.47 times 9 plus 68.4. Enter. And we get a prediction of, was it 72.63, I think? Yeah. So our equation predicts that in the year 2009, the distance for this discus throw for John would be 72.63. Of course, unless he broke his arm in that year or something, then it'd probably be less. So All right, for the next problem, again, we have years, so let's do this. Let's let 1990 be year 0, 1991 be year 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Oh, on this one, we don't need all the data, though. It says, write the slope-intercept form of the equation for the line of fit using the points representing 1992 and 2000. So we just want this point and this point. So we're going to enter 2, 1992, that point, and then we're going to enter 10, 14.7. in our calculator. So, and we can use our list to do this in our linear regression. To clear the list, just highlight L1, press clear, and then enter. And then highlight L2, clear, enter. And the data we were using was, you guys help me remember, 2 and 1992. No, what was the value? 10 point something, wasn't it? 10 point what? What was year 2? 15.9? Sorry, had that wrong. 15.9. Enter. And then the other year we wanted was year 10, 14.7. Whoops, I wrote something wrong here, you guys, didn't I? Sorry about that. I should have wrote 15.9 here. Thanks, Lily. Okay, so 2, 15.9, 10, 14.7. All right. Once you have that data in, again, quit out of there, do second mode. Make sure I go. Okay. And we can run the linear regression again, and it'll give us the equation. And to do that, you press Stat, Calc number 4, press Enter, and there's the equation. The slope is negative 0.15, the y-intercept is 16.2. So we're going to write y equals negative 0.15x, and the y-intercept was 16.2, so plus 16.2. There's our equation. And then number 4, we have to predict the birth rate in 2005. And for 2005, what number would we use? Yeah, that would be 15. So we're going to input 15 into x into our equation. So we're going to do negative 0.15 times 15 plus 16.2. Times 15 plus 16.2. Enter. Did you get that? 13.95. And that's our prediction. So we're thinking in the year 2005, the birth rate will be, what was that number again? 13.95. Now remember, that's per 1,000, so we maybe should say that per 1,000. Now, one thing we should think about is, how accurate do you think that is? Since we went beyond the data, we're extrapolating is the word for it. But you have to sometimes be careful about going too far beyond the data. If you're predicting outside of the data you have, it's likely to be less accurate. Anyway, all right, guys, try the other ones, and then you can redo that quiz.